So in this last video for Chapter 8, we're going to look at how to tie everything together now to solve equations dealing with radicals. Now there's pretty much two key things that we need to know for this section. The first is highlighted here. This pretty much sums up everything that you need to know really to solve it. And that's when solving an equation containing a single radical, that's the nth root, raise both sides to the nth power. Let's look at a story problem and see how we use that. Imagine spinning a ball in a string around in a circle. If the string breaks, the ball will follow a straight line path in the direction it was traveling at the time of the break, as shown here. The ball will travel at a velocity v given by this formula, where T is the tension on the string in newtons, m is the mass of the ball in kilograms, and r is the length of the string in meters. So the question is asking us what tension, so we need to find out what T is needed to allow a 5 kilogram ball on a 2 meter string to achieve a velocity of 10 meters per second. Well, my first step is to take and plug in all the information that they gave us in this last sentence here into the formula that they gave us earlier. So instead of v, we know the velocity is going to be 10 meters per second. So I'm going to say 10 equals the square root. Remember, they say what tension is needed, so T is what we're trying to find. R is the length of the string in meters, and it says it's on a 2 meter string, so it's going to be T times 2 is going to be in the numerator. And M is the mass of the ball. And it's a 5 kilogram ball, so 5 is going to go in the denominator. Okay, so to simplify this, I need to get rid of this radical. Well, remember it's a square root, so just like this highlighted sentence said at the beginning, I need to take and raise each side to the nth power. So this is a square root, so I'm going to raise each side to the second power. That undoes the radical, so those two things now are gone. So on the left side, 10 squared is 100. On the right side, when I took and squared the radical, they undid each other. So I'm left with just what's underneath the radical. So I'm going to write this as 2t divided by 5. Now, just like we've seen in the past, I want to get rid of this fraction, so I can multiply both sides by what's in the denominator. So multiply both sides by 5. So I have 5 times 100, which is 500. On the right side, I have 2t. Divide both sides by 2. I get that T, the tension of the string, is going to be 250 newtons. There's my answer. So why don't you guys try the same problem now, or try doing the same thing now for example 1b. Try it on your own, so pause the video and hit play when you're ready to check your answer. Okay, so this time you're dealing with a 4 kilogram ball on a 2.5 meter string. And we're trying to figure out how much tension is needed to achieve a velocity of 12 meters per second. So since our velocity is 12 meters per second, that's what goes on the left. 12 equals a square root. And then it'll be, again, we're trying to figure out the tension when we know that we have a 2.5 meter string. And a 4 kilogram ball is on the string. Okay, so now we want to take and square each side. Now just a note on this, it's not always going to be squared. It all depends on what the root is. We know that for this one, since there's no number here, that we know that it's a square root. If it had been a cubed root, we would cube each side. If it had been a fourth root, we'd take each side to the fourth power. So just make sure you're looking for that to know what exponent to use. Okay, so back to this particular problem, 12 squared is 144. And then on the right side, I have 2.5t all divided by 4. Multiply both sides by 4. When you do that, you get 576 equals 2.5t. Divide both sides by 2.5, and you end up getting 230.4 And again, that would be in newtons. Now, one final note about doing these types of problems is you always want to check your work with the original equation to avoid what we call extraneous solutions. Now notice in that word extraneous we see this prefix extra. Just means that sometimes we could end up getting a solution even though we did everything absolutely correct. We could end up getting a solution that ends up not working when we go to check it in our original equation. And in that case, then there is no solution. Okay, so let's look at this particular problem. Here we have 5 minus the 6th root of x equals 8. By the way, a note on getting rid of the radical, you always want to get everything all by itself, or everything on one side of the equation, and get the radical all by itself on the other side. So for this particular problem, I am going to subtract 5 from both sides, leaving me with negative 6th root of x equals 3. Because I subtracted 5 from both sides. Now I have the 6th root by itself. Now I want to raise each side to the 6th power to get rid of that 6th root. Now I have a negative number being raised to an even exponent, so that means that this is going to be a positive x on the left. And 3 to the 6th power gives me 729 as my answer. Again, you want to check your answer, make sure that this works and it's not an extraneous solution. So to check it, we're going to put it in the original equation. So it's going to be 5 minus 6th root of 729. You want to check and make sure that equals 8. Well, the 6th root of 729, we know that that's going to end up being 3. But 5 minus 3 equals 2, and that does not equal 8. So we've just demonstrated there that this is not a solution. So this is what we call an extraneous solution. So what we would put as our answers, we would just say no solution. Because there's no number you could put in there for x that would give you a positive 8 as your answer. Why don't you guys try the next one on your own? Make sure to check your work and hit play when you're ready to go. Okay. So let's check to see how you did on this. What we're going to do is we're going to subtract 12 from both sides. So I have a negative 4th root of x. Move that negative down. Make sure that it's not a negative exponent. Okay, so we have a negative 4th root of x. 20 minus 12 gives me 8. Raise each side to the 4th power. Gives me a negative number to the 4th power, or a negative number to an even power means it's positive. So this is just going to be x equals, and 8 to the 4th power is 4096. Let's check our answers. And when I replace x with 4096, I want to see, do I get 20 as my answer? Well, the 4th root of 4096 is going to be 8. And 12 minus 8 is 4, and that doesn't equal 20. So therefore, this is an extraneous solution again, so we would say that there is no solution here. Okay, so hopefully that made sense to you, and they'll help on your homework. Good luck.